Okay, welcome once again. Uh, in the second part of the chapter, alcohol, phenol, and ether. Okay, in the last class, we have studied the chemical properties of alcohol, preparation of alcohol, and preparations for phenols. We have studied the types of alcohols, primary, secondary, tertiary. Okay, now let us start with the physical properties of the phenol, and then we will study the chemical properties of the phenol. In the physical properties, guys, the boiling point of phenol is comparatively higher. The first basic reason, its molecular mass is quite higher, but at the same time, we can see that the OH group, hydroxyl group present on the benzene ring is making a hydrogen bond. You can see here the hydrogen bond. So there is a intermolecular hydrogen bonding, and because of this, the boiling point of phenol is high. Solubility of the phenol is due to the ability to form the hydrogen bond. Phenol is not very much soluble, but yes, it gets dissolved in the water because it is capable of making hydrogen bond, just like the alcohol. Now here you can see the alcohol molecule. This is R group connected with OH. The alcohol is water soluble, but phenol has also a quite good solubility in water because of tendency of its making hydrogen bond with the water. So these are the physical properties which are given in the textbook. Now let us talk about the chemical properties of phenol. Chemical properties of phenol. There are various properties, like you can list it out as many as chemical properties of phenol, because the phenol is a very basic molecule of the aromatic compound, and mainly it is used as a raw material for making many higher complex molecules. Okay, so let us go one by one. You can talk about reaction with reactive metals like sodium, like sodium. So what happens here is the phenol reacts with sodium metal. So here the sodium displaces this hydrogen. Hydrogen is here less reactive. So sodium displaces this hydrogen, and we get the sodium phenoxide ion. Okay, sodium phenoxide you can call it. Sodium phenoxide. sodium phenoxide. Similar reaction we can get reaction with NaOH. Again here the phenol reacts with NaOH. You can consider as an acid-base reaction. Okay. Again the sodium phenoxide is formed here. Sodium phenoxide is formed plus H2O. In the previous reaction we had hydrogen gas released. So these are the two reactions where you can say that the phenol behaves as a acid. It has a slightly acidic property. How much phenol is the acidic? So here in this case, you can say that the phenol can change the color of litmus, that is blue litmus to red, to red. That means it shows acidic nature, acidic nature. But surprisingly, you will find that it does not react with sodium bicarbonate, which it has to react as acid. Like all the acid, carboxylic acids react with sodium bicarbonate, that is baking soda, and evolves carbon dioxide. But the phenol does not show any reaction. So how do we see the acidity of phenol? Phenol is acidic to change the blue litmus to red, but it's not that acidic that it reacts with sodium bicarbonate. So if you have to compare the acidic nature of phenol with carboxylic acid, then it is weak acid, much weak acid compared to carboxylic acid. So this we have to remember as a note. So suppose if there is a question comes, okay, that how will you distinguish between phenol and carboxylic acid? So you can consider this as a chemical test for phenol, that phenol do not react with sodium bicarbonate, but carboxylic acid does to produce the carbon dioxide gas. Now let us see the third reaction of phenol. Phenol also reacts with acid chloride, thus reaction with acid chloride. How we see the acid chlorides? Acid chlorides are R group, carbonyl carbon, and Cl. Call it acid chloride. Carbonyl chloride, alkyl carbonyl chloride. Okay, this is alkyl carbonyl chloride, or you simply call it alkyl acid chloride. Reaction is again a simple reaction, the phenol plus RCOOCl. Now remember the carbon here is very positive. Carbon here is very positive because there are two very highly electronegative elements are connected with this carbon. Now in phenol, if you see, sorry, because of the oxygen here, okay, oxygen is negative, hydrogen is positive, fine. So carbonyl, this carbon attacks on the oxygen to give us the product C, sorry, O, oxygen getting connected with the carbon, carbon, double bond O and R group. So we are having here ester group, C double O. Okay, ester is formed minus HCl, minus HCl. Okay, this is called acetylation, acetylation. Sorry, acetylation, because we are adding here acetyl group to the benzene. Acetylation. Benzene reaction with, see the reaction with acid and hydride. Again, give the similar reaction, acid and hydride. Similar type of reaction we have studied for alcohol. Okay, so because OH group is common here, have some sort of similar reactions. Okay, acid and hydride. Let us take an example of acetic hydride, CH3CO whole twice oxygen. CH3 C double bond O oxygen CH3 C double bond O oxygen. This, right? This is anhydride. So this is acetic anhydride molecule here. Here what we get? Again we get the ester. Benzene O here, carbon, oxygen, CH3. Again this reaction is called as acetylation. Similar reaction what we have seen here. So here acid chloride, here we are using acid and hydride, right? This reaction takes place in the acidic condition. Let's see the another reaction now. Reaction with ammonia, NH3. How does it react? Now, phenol reacting with NH3, NH3, ZnCl2, zinc chloride at 675 Kelvin. Now, this is the reaction. So far, we have studied the reaction where acids or acid anhydrides, okay, were used here. Now, let us take ammonia. Ammonia is like basic in nature. Get aniline, a very interesting and important reaction. Aniline. Aniline is a raw material for making your benzene diazonium salt, which is a very important intermediate compound for making many different type of aromatic compounds. Remember, okay, in the first chapter, that is alkyl halide, we have studied how to prepare benzene diazonium salt, and for that the raw material was aniline. So we have to remember here how the phenol get converted into aniline. Now we can see the reaction. Now suppose if I have to show the reduction of phenol, what is the meaning of reduction here, right? Reduction of phenol, of phenol. So removal of OH group, removal of OH group will show me the reduction. How to view this reduction reaction? Simple, it is zinc. Usually it is written zinc dust or zinc powder because it increases surface area for the reaction. You can write zinc dust or zinc powder and heating it. Okay, so when the phenol is heated in zinc powder, zinc dust, we get benzene. Again, a very nice important reaction because these are very nice examples which we have to remember for conversion. Benzene is again a very important raw material for making so many other organic compounds. Remember, phenol and nitration. Okay, nitration of phenol. Nitration of phenol, we need a nitrating agent. The nitrating agent is our classical nitrating agent, that is nitric acid. Is nitric acid. For compounds, for nitration, usually we take concentrated nitric acid HNO3 plus concentrated H2SO4. This is a nitrating agent which we are using for benzene. But now here, because the OH group is electron donor group, OH group is electron donor group, what we have is the lone pairs. Oxygen on OH group has two lone pairs, which it actually gives to the benzene and forms a compound, and we will get ortho and para position having more electron density, and that welcomes the electrophile nitronium ion, NO2 plus, okay, easily. So here we do not need a very strong condition for nitration. We just need the dilute nitric acid HNO3, and nitration takes place easily. So phenol, and we get the nitration NO2 at ortho position as well as on the para position. This is the para position. Now, which is more stable? Okay, uh, para nitrophenol is more stable. Now, before we go to the next example of the phenol, let us understand one question which is asked in the board on these two products. The question comes as that out of orthonitrophenol and paranitrophenol, para, paranitrophenol is having higher boiling point, orthonitrophenol. Okay, boiling. Now, what is the reason? Okay, though both compounds they makes both of them are capable of making the hydrogen bonding. So let us understand first. This is orthonitrophenol. Let me draw like this. Let me draw like this. Okay. So what happens is there is a hydrogen bonding. Hydrogen bonding is formed here. This is a hydrogen bonding. The hydrogen of OH group gets attracted by the oxygen of the neighboring nitro group. So there is an attractive force, and which is called as a hydrogen bonding. So this type of hydrogen bonding is called intramolecular. That is within the molecule. Within the molecule, the hydrogen bond is formed. Whereas in para derivative, the para derivative the para derivative, we find that the hydrogen bonding is between two different molecules. Like this is molecule number 1, this is molecule number 2. So the two molecules are attracted here. You can see oxygen and hydrogen. So there is a hydrogen bond. Now, this type of bonding is known as a intermolecular. Intermolecular. So what happens is the second molecule holds the first molecule and does not allow to get converted it into the vapor state easily. So definitely I have to give more energy, and that higher energy will increase its boiling point. So the boiling point, if you see, compare the boiling point, para derivative has higher boiling point compared to ortho. The hydrogen bonding is formed in both the molecules, but in the ortho derivative, there is a intramolecular. So in exam, we are looking here for here are inter inter. These are the two important keywords for writing the answer. It is clear. Next reaction, like suppose what will happen if we react it with a strong nitration using our regular nitrating agent, that is concentrated HNO3 and concentrated H2SO4, our classical nitrating agents. What will happen if the phenol is subjected to concentrated acids? So in this case, concentrated HNO3 plus concentrated get nitration, but your ortho and para position, all these positions get nitrated, and we get a trinitrophenol. This trinitrophenol. And what are the positions? Positions are 2, 4, 6. Okay. So let me write here 2, 2, 4, 6 hyphen, continue the name trinitrophenol, which is also known as, common name is picric acid. Remember this name, okay? Because in entrance exams, you may find the picric acid as one of the option, okay? That on nitration. So we just studied the two type of nitration. One in the dilute condition. In dilute conditions, you will get the mononitrated products like ortho or para. But if we are using a concentrated nitric acid and H2SO4, let us go with the next reaction, that is bromination. What will happen if the nitrate phenol is subjected to bromine? Phenol on bromination. So when we are using Br2, because we need a one common solvent in this two, we have to take bromine in some non-polar solvent like CS2, carbon disulfide. Okay, and you can see the bromination OH. Again, we'll get 2, 4, and 6 tribromo. Okay, tribromo phenol. So that is a fine. If the same reaction is done at lower temperature. Same reaction, if it is done at lower, uh, sorry, there is a small correction. This this bromine is taken in aqueous medium, not the non-polar solvent. In aqueous medium, we get the tribromophenol. Okay, but if we are using bromine in non-polar solvent like CS2, okay, then we get monobromophenol, mono derivatives. Here, ortho and para. And para position. Okay, so this is a reaction in aqueous medium. We'll get the tribromo derivative. Okay, and in non-polar medium like water, because aqueous here water is a polar medium, whereas carbon disulfide is a non-polar medium, we get only we are at either ortho at or para position. Para position, para position is more symmetrical, and hence we get as a major product, the major product. So this is how we see the various reactions of phenol. Let us summarize it once again. So we saw the reaction here. Reaction with the strong, so reactive metals like sodium, Na, sodium phenoxide, NaOH, again sodium phenoxide, acid chlorides and acid anhydrides. We got esters, okay, and with reacting NH3 in the presence of ZnCl2, we got aniline. Reacting phenol with the zinc dust and heating it, we get the benzene. So these are the two star reactions for us, because for conversion, these two reactions are very, very important if we have to convert one product to another. So you can use, or you can take the help of these two reactions. Okay, nitration of the phenol in dilute conditions, we get only ortho-para derivative. And if we are using bromination, so in the aqueous medium, we are getting tribromo derivative. In non-polar medium like carbon disulfide or carbon tetrachloride, we get only mono substitute derivative, that is ortho and para. Para being more symmetrical, we get as a major product. So this is the chemical properties of the. Now let us talk about some important products of alcohols given in the book. Usually, very few questions are asked from that. Today we have did this part, acidic nature of phenol. Why phenol is acidic? Okay, let us understand why phenol is acidic. So phenol, oxygen has two lone pairs. The oxygen gives electron pair to benzene, and we get a stable phenoxide ion. We get the stable phenoxide ion. Okay, here like this. So what happens here, because the oxygen loses its electron, it requires the oxygen. It's in the need of a emergency of electrons, you can say. So that actually pulls the electrons from the hydrogen, and H plus is released easily from here. Okay, so why phenol behaves as a good acid? In this case, we have to discuss the extra stability of phenoxide ion. Phenoxide ion. Because the phenoxide ion, after leaving hydrogen, is stable because of the resonance stability. Okay, phenol is quite good acidic molecule. Okay, but again, it is not that strong that it reacts with sodium bicarbonate. Remember this. It is acidic, but not that acidic. Right? Now, let us go with the esterification we studied with acid anhydride, and acid chlorides. The chemical properties of the alcohol we have already studied in the previous class. This is nitration of the phenol. In the book, alcohol and phenol chemical properties are given side by side. Simultaneously, they are given together. This is the concentrated nitric acid, halogenation, that is Br2 in CS, Br2 in the aqueous medium, we get the tribromo structure. Riemann-Diamond reaction. Guys, all the name reactions are very, very important for board examinations. So phenol, because in aldehydes also we are going to study the same reaction, but again, we have to look about this reaction. Okay, very, very important reaction. Many times it has been asked in the exam. So phenol with CHCl3 chloroform and aqueous NaOH reacting with NaOH, and then acid hydrolysis produces salicylaldehyde. Salicylaldehyde is one of the important raw material for making many medicines. Okay, so it's an important reaction, Riemann-Diamond reaction. Remember it? Many times the students, they ask that name reaction, how to remember, how to learn name reaction. So guys, either you go with the mechanisms, but right now for short duration when the exams are near, mechanism, do not give much importance to the mechanism as of now. You can memorize it. If you keep on writing it again and again, do the practice. Okay, or else if that doesn't work for you, that you cannot memorize, okay, then definitely you can go with the mechanism. But the mechanisms uh, need some time to understand. Fine. And the mechanisms are not there in our syllabus. The mechanisms will not be asked also. So just you have to remember the name reaction with actual chemical reaction. Okay, so we have to memorize this reaction. Phenol with zinc test, we prepared benzene oxidation. Phenol, this reaction in the board exams is asked in complete the chemical following reaction. If you see the past year question paper, direct reaction has been asked. Okay, that they will give complete the chemical reaction. Phenol plus sodium dichromate in H2SO4 acidic. What will the product? The product will be phenol. Remember this. There are some examples like commercially important alcohols like methanol, okay, ethanol. You have to learn them. Just go through it, read them. These are easy to understand, okay. And their preparations, though we have already studied the preparations of alcohol in detail, okay, but these are the industrial preparations. So we have to just go through it, you will learn it. Okay. Now let us come to the preparations of ether. How to prepare the ethers. Next topic. After the phenol, we are having now ethers. Ethers. Now, ethers can be prepared by reacting ROH, replacing it by R group. What we get is ROR group. So let us start these reactions by first method of preparation. Right, topic here, preparation. Preparation of ethers. How do we do? Now, by dehydrating alcohols, we can prepare ethers. First, let's say dehydration of alcohols. How does this happen? Let's see. Dehydration of alcohol. Let us take an example, CH3, CH2OH. This is ethanol. We take two molecules of ethanol and dehydration. We know the dehydrating agent as concentrated H2SO4. We have already done it before. Okay. What we get here is CCO, and we get the diethyl ether. If we take only one molecule of ethanol and do the same reaction, concentrate the product in this case. So we have to take alcohol in excess and concentrated sulfuric acid comparatively low. Temperature is 413. The next method is a very, very important method for preparing ethers. A very important process, that is Williamson synthesis. Williamson synthesis. In fact, this reaction is asked either in the form of a name reaction or application-based type of question will be there. Let us first understand what is Williamson synthesis reaction. In this reaction, alkyl halide reacts with sodium alco oxide. What happens here is sodium and halogen get subtracted, NaX. NaX minus NaX, and ether is formed. R, oxygen, R dash. This is your ether. Okay. Similarly, if we are using OCON, sodium phenoxide, and if we use CH3, let's say Cl, what answer we will get here? We will get benzene, oxygen, CH3. Okay, this is anisole. Anisole. So this is one of the beautiful reaction where we have to see that how the ether is formed. Fine. These are the two important processes of making ethers. Okay, one Williamson synthesis again and dehydration of the alcohol. Now let us go with the chemical properties of ether. This chemical properties of ether. The very first important, reacting it with hydrogen halide. Hydrogen halide. Now here, if we take hydrogen halide as hydrogen iodide,
Yeah.
okay.
Thank you, sir.
So at the temperature, let us first understand the reaction first, and let me write 373 Kelvin. 373 Kelvin, that is the boiling point of the water. You can say 100 degrees centigrade. What we get is alcohol. We have learned the process how to convert alcohol to ether. Now we are learning how to convert ether back to alcohol, and we get RX. RX. Now here X can be Br or iodine. Here X can be bromine or iodine. Okay. If it is iodine, then the reaction is quite better because iodine is a good living reagent here. Okay. So let's say if there is a reaction like C2H4, C2H5, diethyl ether plus HI. Okay. What is the expected product? That will be ROH plus RI. Sorry, because we have it in the ethyl group here, C2H5OH plus C2H5I. Okay, but there's a small uh, twist in this reaction. Suppose if I use HI, same reaction, but if HI is in excess, if it is in excess, then what will happen? The reaction will get over with the major product of iodide. Ethyl iodide will be the major product. In fact, we will not get alcohol. C2H5OH will not be obtained. So we have to remember, if the question comes HI limited, if nothing is written, then this is the reaction. But if it is in excess of HI, then what we'll get? We'll get the ethyl iodide as a major product. Now, in this reaction of ether with follows with a nucleophilic substitution. Okay. Now, how do we get? Say, for example, I have a reactant carbon, 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 and I have and HI. So, what could be the possible product? That means, okay. So you can write carbon, 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 iodine plus CH3OH. So this is one possibility. You may think there is another possibility is for the same reaction. There is a possibility that we may get the tertiary alcohol and methyl iodide. So we have another set of products here. So which is more? Which reaction is the correct here? Okay, which is the correct reaction here? Now, because here the iodide is going to attack, Okay, so what will happen? This is on the oxygen. Okay, hydrogen. The reaction will end up with step 1 or reaction type 1. We will not get second possibility. We will get the first possible products. So methyl alcohol will be formed here. Now, what is the reason behind this? The reason is the departure of leaving group CH3OH. Departure means if I remove this group from here, CH3OH, departure of CH3OH will make a stable carbocation. That means if the hydrogen goes here with this oxygen, we will have a stable carbocation and CH3OH. Okay, so because of this stability, now it will react with my negative iodine. Okay, so you have to remember this. Okay, first carbocation you have to make. First of all, you have to make a alcohol. Okay, first you make the alcohol, then you make the iodine. So for example, if second process goes, so I will be having methyl cation here, methyl carbocation. Now methyl carbocation is not stable, okay, compared to my tertiary carbocation. Tertiary carbocation is more stable. So here we have to go with the first type of reaction. So here we will not get this product. Okay, so this is what we have to understand from this reaction. Now, basically, almost reactions, chemical properties of ethers. These are the two important processes we have studied. There are few more chemical properties are given Especially few name reactions are there in the book, which we have to learn most. That is Kolbe's reaction, Kolbe's reaction, and in the continuity we are having Riemer Tiemann reaction, guys. This is again we have done it. Riemer Tiemann reaction. These are the name reactions which are very important. Okay, and we have to prove it. Fine. So important reactions: Williamson synthesis reaction, Williamson synthesis reaction, reaction of ether and HI. Remember this, a very important reaction. Okay, so out of this four, usually one or two is definitely there in any board paper, because here there is a give reason type, very beautiful give reason type question is can be framed here. Williamson synthesis or Kolbe's or Riemer Tiemann. Either this name reactions will be there in the form of a conversion, or directly the question comes write a note on this name reaction. Okay, so by this, with this, we can finish up our chapter. Okay, so in the next class, we will start with another chemistry chapter. Guys, at that time you just practice more. Okay, and best of luck for the examination. Thank you very much.